Hello everyone, I am Lynn. Today in this video I would like to discuss about the fundamental principle of counting. This principle is the basic concept of counting. This principle is the act of counting without counting. By using this principle, we can determine the number of different ways of arranging and selecting objects without accurately listing them. These concepts should be studied before studying permutation and combination. What is the fundamental principle of counting? If one operation can be performed independently in M1 different ways, and if a second operation can be performed in M2 different ways, and a third operation can be performed in M3 different ways, and so on, for any finite number of operations, then a total number of ways in which all the operations can be performed in the stated order is M1 multiplied by M2 multiplied by M3 and so on. By using this principle, I will solve a lot of problems. Firstly, I want to discuss one example by using fundamental principle of counting and without using fundamental principles of counting. Firstly, I want to discuss without using fundamental principles of counting. Okay, let's go. How many numbers of 2 digits can be found out of the digits 1, 2, 3, and 4? No digits being repeated. Okay, here 2 digits. 2 digits means it has tens digits and unit digits. Let us consider. We have there are 4 digits. 1, 2, 3, and 4. Yeah. Firstly, I want to choose one of digits from given 4 digits. If I choose 1, I can't use ones in the place units digits. So I can choose 2, 3, and 4. Okay, if I choose 2 for the 10 digits, I can choose for the units 1, 3, and 4. Then if I choose 3 for the 10 digits, then I can use 1, 2, and 4. If I choose 4 as the 10 digits, then for the unit digits, I can choose only 1, 2, and 3. Okay, from these 3 diagrams, we get possible numbers like that. If 10 digits is 1, unit digits is 2. Possible numbers may, 12. Similarly, 30, 40, 21, 23, 24, 31, 32, 34, 41, 42, 43. Let's count how many numbers we can get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 numbers can be formed. Yeah. Let's try with fundamental principle of counting. Let's with fundamental principle of counting. How many numbers of two digits can be found out of the digits 1, 2, 3, and 4? No digits being repeated. Okay, similarly, we have to consider two digits or 10 digits and units. We can choose from these four numbers. So, I can choose one or a number from these four numbers. So, for the tens, I have four ways. Okay. If I use one number has chosen, we can choose this number again because no digits being repeated. So I have to choose one number from the remaining or three numbers for the units. So for the units, I have three ways. So numbers of number may well 4 multiplied by 3 equal 12 ways. Let's consider other examples. From now, I will find solutions with using the fundamental principles of counting. Okay, there is a candidate for 3 posts. In how many ways can the post be filled? Okay, in this problem, 6 candidates. Post is 3 posts. Let's consider. First post, second post, and third post. Let's consider for the first post. For the first post, there are 6 candidates. So it has 6 ways. If one candidate gets this vote, there are only 5 candidates for the second post. So for the second post has only 5 ways. And there are 4 candidates left for the third post. So for the third post, there are 4 ways. How many ways can the post be filled? The post can be filled equals 6 multiplied by 5 multiplied by 4 equal 120 ways. Let's continue. Number 3. There are 50 buses running between Delhi and Mumbai. In how many ways can a man go to Mumbai and return by a different buses, not the same bus? Okay, men will go Delhi to Mumbai. He can choose from Delhi to Mumbai. There are 50 buses. Okay, she can choose one buses from 50 buses. Then he returned from Mumbai to Delhi. He chose different buses. So he have only 4 buses. So both the events can be performed. So my God. Both the events can be performed equal 15 multiplied by 40. So 210 ways. The next one. A code what? It consists of 2 distinct English alphabets. Okay, English alphabet. Distinct English alphabet. Distinct English alphabet. How many distinct English alphabets do you know? Yeah, there are 26. And followed by 2 distant numbers. Distant number. 2 distant numbers between 1 and 9. Between 1 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For example, CA23 is a code what? Okay, code what? Code what? Like that. CA23. It's first place, second place, third place, fourth place. How many such code words are there? How many such code words are there? Okay, let's try. For the first place, it's distant English alphabet. It is English alphabet. We can choose one alphabet from 26 words, 26 alphabets. So for the first place, maybe 26 way. Okay. For the second place is also the English alphabet. Here, we have chosen one alphabet from 26. So, we have second alphabet can be selected in 25 ways. Okay, and the third place. The third place is number. So, third place number, we can choose, we can, the, the first digits can be selected in 9 ways. The second digits can be selected in only 8 ways. So, the number or distinct code the number of distant codes begin 26 multiplied by 25 multiplied by 9 multiplied by 8 equal 46,000 and 46,800 weights. We have another instruction left. How many of them? And with even integers. Okay. How many of them and with even integer? Okay, let's try it again. C A 2 3. This is for first place. This is for second place. This is for third place. This is for fourth place. There is no problems for first and second place because the first place is alphabet. So for the first place can be selected from 26 alphabet. Then for the second place is also English alphabet. So we can choose the ones from the remaining 25 alphabets. And the third and fourth place, let's consider. We want and with an even integer. For the even integer, we can determine by less work. So the number between 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 2 is an even integer. 4 is an even integer, 6 is an even integer, and 8 is an even integer. So there are 4 numbers for the even integers. So the fourth place, we have to choose from these 4 numbers. To distant, we can choose all the number or the integer. 9, we have the tens place can be filled up in only 8 ways. So the number says code begin 26 multiplied by 25 multiplied by 8 multiplied by 4 equal 20,000 and oh my god 800 ways. This is next number. Number 5. It has decided that a flat of a newly formed foreign will be in the form of 3 blocks, each color differently. If there are 5 different colors in the whole to choose from, how many such designs are possible? Okay, it has 3 blocks. 3 blocks. Each color differently. if there are 5 different colors, how many such designs are possible? Each color differently. Each color differently. Okay, for the bust, I have and can choose the first plot can be colored in 5 ways. To be differently, for the second block can be colored only 4 ways because amended by colors one word had been used for the first block, and there are 4 remaining colors to choose from. Then the last block can be colored only in 3 ways to be differently. So, by the fundamental principle of counting, the number of flags design equal 5 multiplied by 4 multiplied by 3. So the answer is 60 ways. The next one. There are 6 multiple choice questions in an examination. How many sequential answers are possible? If the first 3 questions have 4 choices each and the next 3 have 5 each. Okay, there are 6 multiple choice questions. Okay, first question, second question, third question, fourth question, fifth question, sixth question. For the first questions, the first 3 questions had 4 choices. So, first question has 4 choices. Similarly, second question has 4 choices. Third question also have 4 choices. And the next 3 have 5 choices. So, number 4 question has 5 choices. Fifth question also 5 choices. And sixth question also 5 choices. So, by the fundamental principle of counting, sequential answers are 4 multiplied by 4 multiplied by 4 multiplied by 5 multiplied by 5 multiplied by 5 equal 8,000 weights. Similarly, the next question. There are 6 multiple choice questions in an examination. How many sequential answers are possible? The first 2 questions have 3 choices. The next 2 have 4 choices. And the last 2 have 5 choices. Okay, let's solve. First question, 3 choices. Second question, also 3 choices. Third question, 4 choices. Fourth question, 4 choices. Fifth question, 5 choices. Sixth question, 5 choices. So, sequential answer 3 multiplied by 3 multiplied by 4 multiplied by 4 multiplied by 5 multiplied by 5 equal 3,600. A team consists of 6 boys and 4 girls, and the other has 5 boys and 3 girls. How many single matches can be arranged between the two teams? One, a boy plays against a boy. A girl plays against a girl. Okay. First team, 6 boys, 4 girls. Second team, 5 boys and 3 girls. How many single matches can be arranged between two teams? When a boy plays, okay, all the boy plays against a boy. The number of single single matches between boys of two teams equal 15 has 6 boys, so 6 way multiply by. Second team has 5 boys, so it has 5 way. So number of single matches begin 30. Next, the number of single matches between girls of two teams equal 15 has 4 girls, so it has 4 way. Multiply by second it has 3 girls, so it has 3 way. So the total single matches begin 12. How many single matches can be arranged between two teams? So the total matches begin. Number of total matches equal 30 plus 12 equal 42. In how many ways can this diagram be colored subjected to the following two conditions? This diagram be colored. A. Each of smaller triangles to be painted with 1 or 3 colors, red, blue, or green. Each or each odd smaller triangle is to be painted with 1 or 3 colors, red, blue, or green. B. No two adjacent regions receive the same color. Okay, for number A, there are 4 triangles. For number A, the given diagram can be colored For the bust triangle, we can choose three colors: red, blue, or green. And also, second triangle, we can choose three colors. For the third triangle, we can choose three colors. For the fourth triangle, we can choose three colors. It has 8 units. Number B. No two adjacent regions receive the same color. Okay. Zero color. I will paint the central triangles with 1 or 3 colors. Hello? Ê con này,